Hi, it's Ms. Carpenter from Humble Pie. Today in the box we have dice, green and white, and they are going to represent something you can do as a little game. You could print off a grid and you could use the green for Y just because I designated green. And I'm going to use this one for X, but you don't have to do that. It's just an idea. And then when we roll it, this would be my first point, 2 on the Y, and this would be, so we should really do these in the other order. This would be 6. So my point, my ordered pair would be 6, 2. So I would go along the X till I got to 6, and then I would go up 2 floors on the Y axis. So 6, 2, my ordered pair would be right here, and then I could do it again. And this time I've got 4 on X and 2 on Y. So I go over to X, go 4, 1, 2, 3, 4, and up 2. Now I have 2 points. I can plot those 2 points, and with only 2 points, you can make a straight line. And remember, we're talking about straight lines. And that is why, last video, we had French fry socks. The French fries, when they're straight, you can use y equals mx plus b to represent if we were to put a French fry right here. That's the first reason we had the French fry sock. If it's a curved French fry, you can't use y equals mx plus b. That's only for straight lines. Y equals mx plus b. Then we've got this guy. He's sliding. So he's on a sled. Well, we're going to talk about a hill and how it is sloped. Last thing in the box, potato. We're finally going to get to use the potato today. French fry, potato. Okay, so when we're talking about our ordered pairs, remember that when you write it, you put it in brackets like that that are curved. And those curved brackets mean the order matters. We always go X first because it's alphabetical, X, Y. X represents where it is on the X-axis in relation to the numbers. Y represents where it is on the Y-axis. So you can see I've already put this line. So our first ordered pair is -2, -1. So -2 on the X-axis has to go left. 1, 2. -1 on the Y-axis, we have to go down 1. Okay, so our first ordered pair goes right here. Our very first point is right here. Then we go to -1, 0, 0, -1, or 0, +1, another mistake. Then we go 1, 2, 2, 3, and 3, 4. It keeps going, that's why I put the dots. On this side, it does not. It starts here. Now, last time we talked about B for begin, Y begin. So this letter right here, B, do you remember what it represented? That's right. It represented where we began on the Y-axis. Well, B, this time, we're beginning down here, technically. But Y begin, where does it begin on the Y-axis? Right here. Where is it on the Y-axis? It's right here. That's when it intercepts the Y-axis. And what is it called when it intercepts the Y-axis? The Y-intercept. Easy. Okay, let's use some color because our brains love color. So where did I put the color? Maybe in my tool belt. Nope. Aha! So for Y and X, X is orange, and we're going to remember that X is like an xylophone, that's why it's this way, and Y is like a yo-yo, it goes up and down. Okay, so on the X-axis, it's for the Y-intercept, which is also called B, the Y-intercept, because, I don't know why they use B. 0 and 1. And I'm going to use green to put the 1, so it's really clear that the orange is X and the green is Y. And that is actually what these represent. In Y equals mx plus b, Y and X are just the ordered pairs. They could be any of these. All of these will work for the equation of this particular line in this formula. I just noticed the greens are not the same. Oh well. We can't be perfect. But hey, I just found the other green. So y and x values, as long as they're the right pairs, they are pairs. They're like ducks. They mate for life. They have to be the same. You can't put this guy with this guy or you no longer have a straight line. Or you no longer have this particular equation for this line. So you've got to do that. Okay, so these are your x and y values, and you can use them interchangeably with any of these. This b, which I will no longer put in orange, let's use a different color. Let's make that b pink. B is the y-intercept. And remember that that's where it intercepts the y-axis, which means that it has to be 0 on the x. This is the y-axis, and anywhere on this y-axis, I'm not going right or left. I'm staying at the origin for x. I'm not going this way, I'm not going this way, I'm staying here. So that is going to mean that when you have your y-intercept, x is 0. Y could be anything here. For this particular line, y is 1. Okay, now we also talked about the x-intercept, and we weren't surprised to learn that x-intercept is when the line crosses the x-axis. So where does it cross the x-axis? Right here. So this was our y-intercept, and this is our x-intercept. And we abbreviate it like that. So our x-intercept can be anywhere here. Well, what is y always going to be? Y, this is the x-axis, and x can be any of these values, but y is always going to be 0. You're not going up or down on the y-axis when you have your x-intercept. It's actually on the x-axis. Okay, so your x-intercept in this case is going to be when x is 1 and y is 0. And with your intercepts, you always have to realize that one of the values is 0. That's a rule because it has to actually cross the axis. So one of them has to be 0, and it's the opposite one that is 0. So when it's an x-intercept, y is 0. When it's a y-intercept, x is 0. And remember, b begin, y begin. On the y-axis, b is the y-intercept. A lot of students will think that this is the y-intercept just because it has a y. But remember, that is the x and y ordered pair. It could be this one, this one, this one, this one, this one. Okay, so when you see these zeros, I encourage you, when you see a 0, to make note of it because it's going to be important on your axis. Okay, so the other thing we're going to do today is we're finally going to talk about potatoes. So my students one year were having a hard time remembering about slope. So if you're sledding, like our polar bear is sledding, and you're going down the hill like this, you don't have to put any effort. It's very easy. But when you're going up the hill and you're dragging your sled up the hill, my students, I can't even remember why, but I will never forget, envisioned pushing a potato positive. So if your line goes this way, it's going to be positive. But if we had a line that was going in the other direction, like this line going downward would have a negative slope. So the positive slope goes from left to right, as though you're pulling your sled or you're pushing your potato. That is positive. Actually, I should do that in blue. That's positive. Positive slope. This one is negative. And why is it called a slope? Well, if I say to you, I'm going over there to that hill to go sliding or sledding, and I say it's a really steep slope, you know what I mean. If it's like this, that's a pretty good slope. If it's like this, that is a steep hill. That is a very steep slope. So we use slope just in the same way that we would use it to describe a ski hill or a sledding hill. If it's a gentle slope like this, that's going to be a smaller slope. But if it's really steep, that's going to have a bigger slope. So the key word is S-L-O-P-E, slope. That means the steepness of your line. So we can calculate exactly where this line is going to go using slope. Now, does that make you go, I hope so, because that M, that that M right there stands for slope. So let's erase all of this because we're getting kind of visually crazy here. And we're going to say in this, M is slope. Another way my students remember it is they imagine this as a mountain, two kind of mountains, and that you're skiing on it or sledding on it. Wow, neither one is going to be easy to draw for me. Hey, extraordinarily long legs. Sledding on this slope. So M, which is like your mountain, is your slope. And that's everything for this time. See you next time.